Let's do some system design for our Instagram. And before going to system design, we need to look into the few basic concepts. What are all the basic foundations that we need to have in paper to solve our design? The first thing is the business requirement. So we need to understand the business requirement fully. So what Instagram does, if you have any doubts, please get this clarified from the interviewer. And then the second thing is technical requirement. So once we conclude the business requirement, we need to look into the technical requirement of this. Once we conclude the technical requirement, we need to plan for the capacity. So how our system should work, what is the max limit, etc. And then post capacity planning, we need to discuss on the database schema. So which is the major and then the pivotal role here. And after database schema, we need to use the use case discussion. So we need to validate whether all our use case fit into our database schema and is it scalable. Once it is done, we can go for the design. So after designing our code or the system, we can move to our APIs. So after designing, we need to check for the APIs, what are all the APIs that our system will have. And once APIs are done, we need to have a flow diagram or flow discussions. So we need to discuss each and every flow. So here, let's go one by one. So first thing is the business requirement. What is a business requirement? We all know that Instagram is a photo sharing app. So users should able to upload the images. And here we can have the sub requirement like it should support like a JPEG, etc. The image support, and then GIF or any other format, MPG, IMG, etc. And then likes and comment. So once the image is posted by a user, the another user can able to like and comment this post, and then follow other user. I can able to follow my friends, and then friends can able to follow mine, and news feeds. So this should be based on the relevance of the user. So once the user opens the newsfeed, he should able to see the post of his friends based in the sorted order, and also it should be in the sorted order. So this is a business requirement. And what are all the other requirement? This is the authentication, which is nothing but the credential entering, password, username. We can this is not a basic business requirement because we have the third parties like Google, Facebook are providing us. It's just going to be calling those services. So we don't need to discuss this as part of this system design. And then messaging system. Yeah, it is a very important feature, but we can discuss this when we discuss on the WhatsApp system design. And then analytics, we can discuss this as well, and then add feature. So within the 35 to 45 minutes of your interview time, we need to have the important feature should be discussed. So let's focus on these four things as a business requirement. Next thing is the technical requirement. In the technical requirement, first thing is the image support. We need to support for GIF, PNG, and JPEG. For example, if the user downloads from iOS, uploads the image from the iOS, then the image format will be in IMG. So we need to support all the platforms like iOS, Windows, and then Android, etc. So we need to focus this. And then the size of each image. So let's have a max limit of 10 MB. So this technical requirement involves our technical discussion and also the assumptions that we are going to make. So under which our system will work. So that you can get clarified with the interviewer, or is this assumptions are right or wrong, or do we need to add something with respect to the tech, etc. And then the concurrency. Consider like we can have concurrent uploads of 1 lakh, like 1 lakh users will upload the images at the same time. That's the concurrency. And then the image uploads, a user can do the 10 images per day and maximum of 500 images per user per month. Let's have this as a max thing. So this will be very helpful for to calculate our storage capacity. So we need to calculate our storage capacity based on this, and then we can plan for that. And then likes and comments. So we can have like 1 million per post can have 1 million likes or comments. So this is the max limit that we have, and then 1 billion user base for now. Let's deep dive into the capacity planning. So for the major part in the Instagram is the image storage. So the storage involves image storage and also the relational database, the information, that info about that image. So which it can be called as a metadata storage. So let's have two things. One is image, another thing is the metadata storage. So how can we, let's plan for the image storage. So let's assume that average image size will be 5 MB and then each user uploads 10 image per day. So in that case, how many max storage that we can have per month? It will be 5 MB into 10 into 30. This is a some petabyte, some X petabyte of storage. So per month, our system will need this much storage amount. So if we need this, then what is the next thing? For example, if we if it is more than 1 month, then what we are going to do, then we can plan for moving the older images to some archive location so that we can get those images not in a frequent way. These and all points will get you a bonus things. Okay, and then the next thing is the network bandwidth. What is a bandwidth? Bandwidth is nothing but if you have a pipe or a wire, in this the data will flow like water. So this is a bandwidth. So in this pipe per second, how many GB of data that this pipe can handle. So this is a network bandwidth. This will be helpful in calculating our computation power in selecting our instances. For example, if you select the EC2 instance, then we need to take these things in our mind. So the average upload time, so assume that our average upload time is 5 seconds for an image. Then the concurrency is 1 million. So 1 million image will be uploaded concurrently. So in that case, it will be have a 1 million images. So in that 1 million, then what should be the bandwidth that we need to have? Then it should be around 50 GB per second. So we need to support this. Next thing is the compute resource. Compute resource are nothing but the EC2 machines, EC2 or your local PC. Okay, so how these EC2 machines can have a parallel processing? It depends upon the cores, the server cores. So my system has 10 core. Then each core can have 2 threads. So that means I can span up to 20 parallel threads. So similarly, we can have different system requirements. So in this case, the concurrent uploads is 1 lakh uploads. Then the processing core, if we have 1 lakh, then sorry. So in that case, we should have, if we have 32 servers, then this is a total servers that if we need a 32 core server, if we have 32 core server, then how many servers we need? We need around 3000 servers. So 3000 PCs has to run to scale our Instagram. So this is kind of a quite large servers that we need to for our computation purpose. The next major part that we are going to discuss is the database schema. So while having a database schema, make sure we have a relationship in place, which is nothing but your um, foreign key or something in the layman terms. So here, users table have user ID, username, email, password, and then post has post ID, user ID, caption, image URL. That means user can have the post, not the post. So it is one-to-end relation. One user can have n post. And also when we check with the post to user relation, then one post can be linked to only one user. And similarly, like, right? So like is linked with both the post as well as the user. And also the comment. Comment is linked with the both user and the post. And then the follow is linked only with the user. When you see, you will have okay. So if I put this database schema, then is my schema is valid or not? Then how can I validate it? You can just cross check by putting some of the use cases. So say I'm going over my news page and then I am going to select a post to view. Then that post should get me the number of likes that it has. Then how can I can just query this table, and for this particular post ID, how many likes I have, and then who is the follower of user X. Then I can just have this table and select the query and then get the values of the follower user IDs, and then we can join with the user to get the user information. So that's a basic thing. So this is a basic database schema that we can have for our Instagram system. The next thing, yeah, this is what we have discussed, use case discussion. So number of likes of a post and get all the post per a user and who follows the user X. All these scenarios can be answered with our database from our schema. So we can say like our schema is holds good, quite good for all to get retrieve all the data. But the point is whether is it scalable or not, it depends upon the system that we are going to design. Let's discuss in future. Let's deep dive into the designing part. So consider who is the user base. So it can be anyone, and then how he is going to access our Instagram. It is going to be some user interface, right? So let it be a UI. And then what is a UI mode? It will be kind of a mobile. Most of the users are from mobile, right? The next thing, we are going to have a single point entry, which is nothing called as API gateway. So why we need this API gateway? So this API gateway will help us to check for authentication and other to stop the users to have some DDoS attack or to do some malicious activity inside our system. So for that we need this API gateway. So for API gateway, we use Amazon's API gateway. So what is the purpose that it is going to serve is, let's say two, it is going to serve many purposes, but let's talk about only two. One is authentication, whether the user is authenticated or not. So this is one of the system, one of the purpose that this serves. The other thing will be the rate limit. So what is the use of rate limit? So the rate limit will help us to stop the malicious activity like DDoS attack, etc. If the users are trying to be from any countries that banned, any countries which are treated as malicious, then we can stop them. Also, we can able to easily identify the bot attacks between this. So what we have done is, this is a user, he will access our system using a user interface which is going to be a mobile, and then there we are going to have a single entry point. It can be of any request that comes. Maybe one is from for post, another one is for follow, another one is to add a user. Okay, so for example, this is for upload image. Okay, so for all the request we are going to have a same thing. This is for add user, and then this is for follow user. Okay, so whatever the things that we get, we will be having a single entry point here. Okay, so just give me a sec, I will just try to be. So, okay. So now what this API gateway is for, API gateway will help us to solve the malicious activities, to avoid the malicious activities. So it also serves as an authentication purpose, and also it serves for the rate limit. The next thing that we are going to do is the backend services. So how the backend will be. So let's start by building a backend service. Okay. So we are going to have a microservices. So to have a microservice, we need to have a API server here. So what is the reason for this API server? Is this API servers will get the request and then serves as a controller. So it get the request and then redirect the request to the corresponding microservices. So what is microservice? Microservice are nothing but a set of implementations which we have segregated and then implemented in a separate compute systems. For example, this is a image service. So what is the use of it? This serves for the purpose of posting an image into Instagram, and also we are going to have a newsfeed service. Okay, so the newsfeed service is responsible for getting the newsfeed relevant to a particular user, and also we are going to have a follow and or like service. So this service, sorry, like or comment service, and then we will be having a user service which will be helpful for adding a new user or to follow a new user. So follow another user, and also we will be having another service which is a fan out service. Let's come back to the fan out later. So now we have done like the from the API gateway, the request will reach the API server, and then from API server it will go to the different microservice based on the request that it comes. If it is comes to an image, upload image, then it will go to the image service. If it is for commenting a new thing, then it will go to the comment or like service. So these and all the different microservices that we are going to have. Microservices. Okay. So with this okay, for now we have done the computation part. Now with this computation part we need to implement the storage. So how the storage will be? So here we are going to have a media file. So for media files to be stored, we need to have a object type of storage. So S3 is the object type that we can use. So as with respect to the AWS, it is S3. With respect to Azure, it will be the blob storage. So from the image service or every microservice, it will access the S3 and store the image. And not only do this, it will also store the metadata information in our database. So this is our relational database. So this can be kind of a Cassandra or some kind of um, it can be a Cassandra or some kind of distributed database, so we can use that. So distributed database are important here, because we are going for better performance and scalability. And yeah, we can distribute the images and based on the user location for easy retrieval, etc. Let it come, we can come back later if we have any questions on that. Okay, so now we got these things, and then yeah, we have written a image service, newsfeed service. It's a newsfeed service, and then comments and like, and then user service, and then fan out. These are all the microservices and S3. Okay, for example, if the user lies in the a different geographical location, then in that case, what we need is we need a content delivery network. What is the use of this content delivery network? Is this will help us to um, this will help us to for example, if the server, if the files are in the Indian location, okay, now the user who wants to access a post lies in US, then this content delivery network will help us to deliver our content in a real time to those users. So it is kind of a caching the image from the India into the geolocations. So it will have a cache of this file in each and every geolocation, so that user can able to easily access. Mainly for the fast retrieval, we need this content delivery. So Amazon CloudFront is one of the content delivery network. And also, if there are some images, right? For example, if the your account is public, then the image stored here will be a public image, so that we can able to share that URL to across the user. If there is some question arises regarding how can we share a public image, so what is a feature that we plan to implement? So based on the user details that are stored in this database, if the user is public, then the image stored in this bucket will also be a public. If the user has his account as a private, then image will be private. So this image will be shown only to the users who are following. So this is a by this way we can have that scenario will be handled. And the next thing that we need to think is the notification service. For example, if the user posted an image and tagged some person, then those notification has to be reached to the other user. So how can we do this? So we can have a pipeline. So what is the use of this queue? It is kind of a queue. So it will separate our flow from the asynchronous flow. So some of the flows can be asynchronous. So if the user uploads an image and tag a person, it doesn't mean like the user has to, the other user who has been tagged has to approve, then only this image will be posted. Okay, right? So what will happen is the user will post the image, it will be saved in S3, and the entry will be saved in our database, and the response will be sent to back to the user. That is, the image got posted. But if someone got tagged, what will happen is this image service will put a message in the queue that this user got tagged in the post, and then this will hit the fan out service. So fan out service or other user service, whatever service that is responsible for that, so that fan out service will read this message and then propose a notification to the other users. So for example, these two users got tagged. So what will happen is this fan out service will send the notification that, hey, you have been tagged by this person and for this post, can you please do the needful? Okay, so this is what is going to happen. And similarly, this fan out service is responsible for sending an email as well for the same people who are need to be notified for that. Okay, so these people will be notified, like there is a notification from Instagram stating your image has, you have been tagged in particular image. Let's have a quick recap on this. The user is going to hit our user interface via email, via mobile, and then it will hit our API gateway, which is a single point entry, and then this will help us to solve the rate limit problems, and also it will serve as an authentication purpose. Once it is done, it is going to reach our backend service, and then in the backend service, every services are written in a separate microservice form. So once the microservice hit, it will store the image in our S3 and also store the metadata information like who accessed the page and then who posted the image and who liked whom, etc. will be stored in this Cassandra. And also we will have a content delivery network for faster access of the post across geographical location, and also we can have the publicly accessed image based on the user settings. And also once it is done, if any tags are happening, we have a fan out service that serves asynchronously for whatever the image notification, etc. that needs to be sent. So this will help us to speed up the other process, and then it will be segregated. So this is a right design that we can have. This is our system that we have designed, and let's see one by one use flow. Like if a use case flow, like if the user wants to upload an image, then this is a flow. It will reach us the API server, and then it will access the image service, store the image in the S3, and also provide and have a metadata information in our database, and then respond. If the image has a tag, then it will be sent to this queue, and then queue will be accessed by this fan out service. That fan out service will say, and then will read the message, and then it will send the notification to the other users. And similarly, if you want to follow other user, then it is kind of the same flow. Instead of having the image service, it will go to the user service and store the data information in our relational database. And once it is done, to have a notification sent to the other user, it will put a message in the queue and it will be taken care by the fan out service, and then the notification will be sent. And then the third thing is to any follow other users, it is going to have the same flow. So this is a high level design of Instagram. So the final thing that we are going to see the number of APIs. So what are all the APIs that we will be having? We will be having the post API. So what are all the post APIs that we will have? Image upload. So image slash upload. And then what we will have other thing is follow other user. So user slash user ID slash follow. So now many will have other questions like we have only one user ID. So that means like here we have two actors. So one user will be following the other user, right? So this user will be following the other user. So in that case, how we can say we have in the API we have only one user ID. So that means like this user information, whoever logged in currently, the current logged in user will be sent as a header in the bearer token. So he will be able to, so here we need to pass on only the target user ID. So this is a follow, and then the other API for like and comment, user slash user ID or post ID, sorry, post ID slash like or comment. So here it will be kind of a image. Yeah. So this is a post APIs that we will have, and with respect to the get API, we will have user slash user ID as a get, and then other will be kind of a post slash ID, and also we will be having a newsfeed. So newsfeed slash. So these are all the get APIs that we will have. So this sums up our system design. So what to have a quick recap, what are all the things that we have done is business requirement. So this is the first thing. Once we are done with the business requirement, we have done the technical requirement. Once we are done with the technical requirement, we need to do the capacity planning. So once we are done with the capacity planning, then we need to design the database. And then once we have done this, then we need to enter into the use case discussion. So why use case? So this will help us to check whether our database design is right. And once it is done, actually go into the design. So the design, and then you just design your APIs, and you can have some bonus information like how you are going to handle the parallelism, how you are going to have a concurrency, etc. So this sums up the entire system design of Instagram. There may be many other good designs as well. It's not a one way to do this, so we can have a multiple solution for a problem. So please comment your point of view as well. This is my point of view, and we can have this as well, which can be scalable.